Hello. Today we are going to look at a recap of the probability that we already know from earlier work. We're going to start off by mentioning the fundamental principle of counting, which is just when we have multiple different events that can have different numbers of possible outcomes, we just multiply all of those outcomes together to get the total number of possible outcomes. So that's our fundamental principle of counting. Probability in general is the number of outcomes we want divided by the total number of possible outcomes. So we can use the fundamental principle of counting often to find the total number of possible outcomes, and then we take the number of outcomes we want and divide it by the total number of possible outcomes, and that's the probability, which we often call capital P. The expected frequency, so there's lots of language in here, but it often is fairly understandable if we think about what the English of the words mean. Expected means how many times would you expect something, or sorry, expected means what would you expect, what do you think is going to happen. And frequency means how many times you would see something. So expected frequency is how many times do I expect to see something. And that's exactly what it is. So EF is often what we call expected frequency, so we don't have to write out the long words, and that's equal to the probability of an outcome multiplied by the number of times we run an experiment, or trial is another word for experiment. And often this will be phrased in questions like, how many times do you expect to see something? How many times tells you I'm looking for expected frequency. And finally, we have in experimental probability questions where we're told that we're running an experiment a bunch of times, we have a version of probability called relative frequency. So frequency again means how often we see something, and relative means relative to the total number of times we run the experiment. So how often do we see something relative to the number of times we have run the experiment. So again, if we can get comfortable with the meaning of the English, it helps us with remembering what we need to do with our questions. So relative frequency is called ORF, capital O or capital F, and it's the number of times we see an event we want divided by the total number of events, the total number of times we ran the experiment. You can see that it's very similar to our definition for probability, and they are effectively the same thing in practice. They're not exactly the same, but we treat them basically the same. So that's what we've got for probability is wanted divided by total. Expected frequency is the probability of getting something by the number of times we try to get it, by the number of times we run our experiment. And relative frequency is very similar to probability. It's the number of events we wanted out of the total number of events in our experiment. How many times did we run the experiment? So if we look at this in the context of a few questions, if we flip two coins, so these are two normal coins, we can imagine we have two euro coins, if we like, and we flip them together, how many possible outcomes would there be? Well, if I flip a coin, I could get a head or a tail. So those are my different outcomes that I could get for each coin. So each coin has two possible outcomes. I could get a head or I could get a tail. Now, if I've got two coins, I have two separate coins that I'm dealing with. That means that I have two possible outcomes for the first one, and to get the total number of possible outcomes, I go two possible outcomes for the second one. So this is my first coin. I could get a head or a tail on my first coin, or on my second coin, I could get a head or a tail. And to find the total number of possible outcomes, I just multiply my two outcomes together, my two number of outcomes together, and I get 4. So anytime we want to figure out how many possible outcomes we've got in total, we figure out how many outcomes there are for each event, each thing individually, and then just multiply them all together. And that will tell us the total number of possible events. Now, a connected question to that is part 2. List the sample space, or all possible outcomes. So sample space here is a special word, a bit like probability or expected frequency, and it just means all of the possible outcomes. So if we're asked for the sample space, we're asked for all of the possible outcomes written out as a list. So what are the possible outcomes? Well, when I flip a coin, I could get a head on the first coin and a head on the second coin. Or I could get a head on the first coin, a tail on the second coin. Or I could get a tail on the first coin and a head on the second coin. Or I could get a tail on the first coin and a tail on the second coin. And at this stage, I've actually written out all of the different possible outcomes that I could have gotten. And if I look at it, I see that I have 4. I could have gotten a head and a head, head tail, tail head, or tail tail. That's 1, 2, 3, 4 different situations that could occur when I flip my 2 coins. And I can see that it's the same as when I multiplied the number of possible outcomes together. So the 4 here refers to these 4 different possible outcomes. And that's, again, the sample space means list out all of your possible outcomes. You can see how I've done that here. I have them in brackets with a little comma in between saying I got a head for the first one, and a head for the second one, a head for the first one, a tail for the second one, and they're all broken up by my brackets here to make it clear this is one event, this is another, this is one outcome, this is another outcome, this is another outcome, this is another outcome. And I can again see in total I have 4. Now, part 3. The coins are flipped 200 times. How many times would you expect to get 2 heads? So, how many times would I expect to see something means expected frequency. So I'm dealing with expected frequency. How many times would I expect to see something tells me I am dealing with expected frequency. So I need to know the probability of my outcome, and I'm going to multiply it by my number of experiments. Now, what's my number of experiments this time? It's going to be 200. I flipped the coins 200 times. So my number of experiments is going to be 200. But what's the probability of getting 2 heads? And we can write that as P of H. That would be our way of keeping track of what we mean. Probability of getting our 2 heads. Well, if we look at our sample space here, our list of all of our possible outcomes, we know that probability is the number of wanted outcomes divided by the total number of outcomes. Well, there's only one situation here where I got a head and a head that meets my explanation. I get one time I get a head and a head out of a total of 4 possible outcomes. Again, we come back to our total number of outcomes being 4. So one time out of my 4 possible outcomes, I get a head and a head. So I have a quarter is my probability of getting a head and a head. So now my expected frequency of getting a head and a head would be a quarter, that's my probability, multiplied by 200, the number of times I ran my experiment, and that is going to be 50. So what does that mean? Because there's a probability of a quarter of getting 2 heads, a quarter of the time I'm going to expect to get 2 heads when I flip my coins. So a quarter of the time I ran the experiment 200 times, and a quarter of the time I expect to get 2 heads. So I think if I run the experiment 200 times, I'm going to get 50 times where I get 2 heads. That's what our expected frequency means. Next step, I have IV. When the coins are flipped 50 times, we get 2 tails 20 times. What is the relative frequency or the probability of getting 2 tails based on this? So now we've got an experiment going on. We're told that if we ran an experiment a particular number of times and we got an outcome a particular number of times, that means we're doing experimental probability, which is relative frequency. So that's going to be our number of wanted events divided by our total number of events. So our relative frequency is going to be our wanted over our total. Again, basically the same idea as probability, though the question works slightly differently. They're not logically the same, but they behave very different. They behave very similarly. So, how many events do I want? Well, I'm asked about my two tails, and they come up 20 times. So my relative frequency of getting my two tails, a tail and a tail, is going to be, I got 20 of them out of a total of 50 times that I did my experiment. So I got two tails 20 times out of a total of 50 times that I ran the experiment. So when I put that into my calculator, I get 2/5, or I could write it as 0.4. And that's all of the different definitions and language that we already know from probability. And that's what we need for now.